operational efficiency, emissions monitoring. My background is on computer science, but I have gained a substantial amount of experience through the years in the maritime sector, also in the logistics and a little bit of marine engineering and naval engineering. And today we are going to present the EO4EU project and the use case that has been implemented in the context of the EO4EU projects, which is about standardizing, harvesting and standardizing Earth observational data to the benefit of numerous parties involved across different sectors. So yeah, I think that's enough from my side. Today, also in the workshop, they are invited, and we thank them very much for the time. Captain, they will probably introduce also themselves, but a short introduction also from Danao Shipping. They are participating, Captain Liovis, Captain Alexandros Magoulas, correct me if the title is not correct, and Nicolas Tagakis, which I think everyone is working on the operations department. Again, correct me if I'm wrong, and you will have also the chance later on to introduce yourselves. Thank you very much for participating and for your time. We understand that you are overloaded, and we thank you.
Perfect. Thank you, Dimitri. I don't know, Christina. Okay. Also, we are having today also our technical team from EO4EU. We are having Haralabos Andreou also from the NKUA from the National Capodistria University of Athens. Bobby, do you want to have 1-2 words? We don't want to waste your time, so probably we can be short enough.
Good morning to everyone. I hope that we will have a very fruitful workshop. Yes, the same thing for us. Okay, so thank you.
Okay, perfect. Marika and Federico are from CMWF. Hello, Christina.
Yeah, hello everyone. I'm Marika Antonacci from ECMWF, and I'm a cloud engineer there, a cloud computing engineer. We are taking care of the infrastructure layer, so the Kubernetes stuff and all the applications that are running on it. So ensuring that everything is working fine.
Okay, thank you very much. Federico?
Hello, I also work at ECMWF as a cloud computing engineer, and yes, we are managing and operating the cloud infrastructure for EO4EU, and we are ensuring that the components are working fine. So we hope the workshop to be fruitful.
Nice, thank you very much. And Christina, of course.
Sorry, I'm Christina Gatsogianni from Center for Security Studies, or else you know that as KEMEA. We belong to the Greek Ministry of Civil Protections and Organization, and we are focusing in search programs just like EO4EU. So I'm a server engineer and geoinformatics engineer, and this is my special field, and we mostly participate here as an evaluator of the project, and of course we guide up the pilots of the project. Thank you.
Thank you. Don't know if the end users will like also Mr. Captain Liodis or Mr. Nikolaos or Alexandros Magoulas or Nicolas Tagakis to have a short introduction. But let's proceed. Dimitri, I will pass the floor to you. We are here about the use case 2. Use case 2, we are use case or a demonstrator of the EO4EU platform related to ocean monitoring. And here we're going to have short, if you can say, introduction about this use case. Please, Dimitri.
Yes, okay. Thank you very much, Katya. So in the next few slides, I'm going to present you what we have implemented in the context of use case 2, which was one of the 5 pilot use cases, as I have said earlier, that validated and guided the implementation of the EO4EU platform. The use case, the title of the use case was ocean monitoring, and generally speaking, it was about how we can harvest the standardized Earth observational data that the EO4EU platform could provide us to enhance operational efficiency, and possibly also to reinvent and redefine with more accurate weather predictions the voyage planning module that we have in our premises. So diving into a little bit of more detail about the use case scope and the generic concept overview. As I said, the focus was and still is, it's an ongoing process on enhancing maritime operations through Earth observational data integration, to bridge the existing voyage optimization module with the EO4EU platform, use advanced data analytics tools and simulation techniques in order to integrate and to fuse the operational data that are coming from the vessels with the Earth observational data, and eventually integrate this data to a diverse set of simulation models related to operational efficiency and voyage planning and so on. The ultimate goal ultimately is to improve the voyage planning in terms of accuracy, in order to increase the level of confidence the end user has to this decision support module, and to increase also in a second stage also the safety and the efficiency of the seagoing vessels. So yeah, the seamless connection between the voyage optimization module and the EO4EU platform was a critical point. Real-time acquisition and integration of weather data sets was another goal, was another point that needed to be addressed by this use case. How we are going to acquire and how we're going to integrate relevant weather data into our existing algorithm. Eventually, we wish to enable adaptive and data-driven voyage decisions to improve, as I said earlier, the fuel efficiency, and to ultimately reduce the environmental footprint and the overall emissions of our fleet. Some examples of the data that we are currently harvesting from the EO4EU platform. Either data that we are currently harvesting from the EO4EU platform, or we wish anyway, they are available to us from the EO4EU platform, and they are linked to numerous use cases addressing a diverse set of needs for the maritime sector. So for Copernicus Marine Environmental Monitoring Service, from Copernicus Marine Environmental Monitoring Service, we can harvest a lot of data to improve the ship routing service and support marine safety also alongside the route, to ensure marine mammal safety. sensitive also aquaculture and air pollution in emission control or SECA areas. We can also have a preliminary image, a preliminary point of view of the hull corrosion, for example, by taking into account and integrating the salinity in specific areas. From Galileo and EGNOS for vessel positioning to enhance the accuracy of GPS signals across the voyage. We can use this data coming from these services to validate the GPS signals by calculating speed through water by taking into account the speed over ground and the currents. The grip to weather forecast dataset by ECMWF by scaling up time and spatial resolution against the current practice for weather routing optimization, followed by the announced today, to enhance time, the spatial and the temporal granularity of the weather datasets that we are currently utilizing. And in your screen below, I have put also some exemplary images that they are coming from satellite that are orbiting the Earth. The first on the left, it's very high resolution satellite imagery that tries to infer the wake fraction of a ship that can be used to possibly infer hydrodynamic performance of the vessel. And on the right of your screen, it is one of the most prominent use cases in the maritime sector that it is realized currently with the use of satellite imagery, which is to identify port congestion and adapt estimated time of arrivals accordingly in order for the vessel to be served in due time and not being stuck in anchorage, which has a high impact on on the environment, as well as it's in running cost for the shipping company, for the owner. A little bit now about the company infrastructure and the EO4EU platform. This is generally in high level the workflow from harvesting continuously the data that are coming from the EO4EU platform. We're talking mainly about weather data. We are establishing there a workflow from data acquisition and data analysis of relevant weather data sets to fuse these data sets with the operational data that are coming from our vessel, and eventually deploy these data sets into our premises, integrate these data sets into our premises, and into our models. We are utilizing a fuel consumption approximation model that consumes this weather data, and eventually this fuel consumption approximation model is utilized as a cost function in the setting of weather routing optimization algorithm, where we can project the savings alongside the fuel consumption savings alongside the route. A little bit about the NAOS weather routing optimization module that it is currently being utilized. So it is a standalone on-board application that allows bridge officers to get the weather forecast, pilot the routes, analyze, optimize them, and report the progress to the office. Some of the onboard features, as I said, weather forecast. We are able to plot multiple routes simultaneously for each leg, consumption estimations and cost analysis, simulating the routes with changing weather conditions. It is an adaptive mechanism, so the user can, depending the weather predictions, the end user can adapt the suggested route on demand. Okay, I'm not going to take a lot of time in these slides. This is for to set the to give you an overview of what we are currently using in terms of routing optimization. As you can see, we are integrating weather data, and our wish by participating in this project was to utilize more granular weather data and quantify the impact that this will have on our algorithm. So I'm passing this slide really rather quickly. Okay, as I was saying, we are able to, through this tool, to simulate the routes and visualize the weather. You can see on the bottom left of your screen, it is the comparison of the wind speed between the actual route that has been conducted in the past by historical data and the optimized, the green. It's the optimization suggestion, and it is steadily below the route that has been conducted in the past. Okay, we can update our position to get the new optimal weather route as we travel, and the forecast is changing. We can set the itinerary and select the intended route for each of the legs. This instantly gets communicated to the office. And okay, this was the NAOS presentation of the tool that we're currently using. And now getting back to the EO4EU platform utilization. So as I said earlier, we are through the EO4EU platform, which is a web-based service with a user interface. We are able to, the user, the end user, is able to instantiate workflows related to ETL pipelines, extract, transform, and load specific data sets. So we can select specific data sets relating to different weather features. Either we are talking about the wind speed or the currents or the wave height and so on. We are using also the Fusion engine that has been implemented also in the context of this platform in order to map the in-situ data from our vessels with the weather data from the platform. And currently we are utilizing either satellite imagery from Sentinel-3 to infer the wind speed from these pictures with the use of machine learning and deep learning models, or we are using NetCDF data, which is, I believe, weather ensemble that gives you a very accurate prediction with a use of a very detailed, very granular grid in terms of spatial resolution as well as temporal resolution. On the left, on the right of your screen, you can see the workflow instantiation. Different components corresponding to different functionalities, which is the sourcing of the data, the acquisition, the processing, and eventually you have like the outcome, which is the wind prediction, that it is ultimately mapped with operational data and transferred. It is deployed to be integrated in the fuel oil consumption approximation model in our premises. Some preliminary results by integrating EO4EU data. Okay, in the left of your screen, you can see the probability distribution of the absolute error by hurricane category. So you have the depression, the storm, category 1, 2, 3, and 5. This is the This is the probability distribution of the mean absolute error between real and predicted wind speed from our machine learning model that infers wind speed from satellite imagery that I showed you earlier from these images. And on the right of your screen, you have again the mean absolute error by the mean absolute error between of the fuel oil consumption by training our model with sensor weather data and with NetCDF data that we have acquired from the EO4EU platform. And you can see that even marginally, but still we have some improvement in terms of mean absolute error in the accuracy anyway of our fuel oil consumption approximation model by integrating Earth observation, EO4EU data that are coming from the EO4EU platform. And finally, some of the routing optimization results by integrating the fuel oil consumption approximation model that it is trained on the EO data. On the left of your screen, you have the accuracy of the fog predictors. So you can see that, I don't know if you can see it, but anyway, on multiple legs, we have benchmark, we have compared the performance of our fog predictor with historical data. And we were able to achieve accuracy above 95%, which is a very robust result. And that gives us the possibility to integrate, let's say, this fuel consumption model into our weather routing optimization algorithm with a certain level of confidence. And we depict here the results of for one leg that has been conducted in the past, and we compare the results between Tangermed and Tampa. We can see approximately 15 tons that has been saved by the optimized route estimation. And by having accurate and granular weather data and a very robust fuel consumption prediction model, that gives you the possibility to argue that these results, the optimization results and the savings that we are depicting here, they will reflect the reality. So you are more eager to, the master of the vessel is more eager to follow, you know, the outcome, the suggestion of the decision support system. Some future steps, and I'm concluding. We need to establish a clear segregation partition between the two versions of the routing module, meaning the onboard and the EO4EU deployed version that it is simulating on premises the results. Possibly introduce a multi-tenant architecture so each user can evaluate the EO4EU powered weather routing module by incorporating their own set of data into the platform. And another possible use case that could be of interest, but okay, from my point of view, maybe it is a far-fetched scenario, is to try to project the supply and demand on wet or dry cargoes by harvesting Earth observational data. And that's all from my side. Thank you very much. And if you have any questions, more than welcome to answer. Thank you.
Thank you, Dimitris. It was quite impressive about how much fuel consumption you can say from probably the models and the weather, if you can say detection and prediction. I don't know if there are any questions. Okay. So I will try to make a presentation and a short introduction of EO4EU and what is the EO4EU that Dimitris has already presented, and how a user can integrate with our platform, and what was the initial purpose of this. Just give me a second. Okay. I don't know if you're seeing my screen.
Yes, Katya.
Okay, so EO4EU project is a European project coming from its 2020. What was the main goal? It was to create, if you can say in simple words, an umbrella of for all Earth observation services that coming from Sentinel-1, Sentinel-2, Sentinel-3, also from all the data providers to be under one, if you can say, platform, one service, and to act as one-stop shop, if you can say, for data acquisition. So we want to facilitate first the data acquisition of Earth observation data. The second thing is to create a knowledge graph in order for a user to help him find all these data sources that are provided through the European Commission, all the data service providers. One user comment was that, okay, probably we can find a service, an Earth observation, for example, the Sentinel Hub, but then the service is changing, the input is changing, the output data are changing through the time. So we have to be quite updated. EO4EU comes in order to go further, to go a step further of this, and to provide you a common interface for all the data services, and to provide also the updatability. I can say that for Sentinel Hub, that we are going also to present you today, for Sentinel-3, data change from RGB images from images to grayscale images. So it was a change adapted, and the user can receive the same output for part. Another thing is data fusion, that we are having pre-processing services, quite quality indicators from the use case providers to provide also to the users to use. Visualization, of course. Dynamic semantic annotation, when we're meaning that we're talking about quite huge data. So we need a downloading and the uploading of data to be compressed, of course, in order to move all this around the cluster, and to have also data analytics visualizations to present to you, except from the data downloading, except from the fusion of data and the processing, except from the machine learning, if you can say, algorithms, all these tool sets, to have also some visualization tools in order to demonstrate your data, either our data as a CSV, raw data, or files with like images on top of a map. What were the challenges? The challenges, as you understand, is the diverse sources and the information. All the data providers has quite different way either to serve the data or to describe the data or how you can access the data. So this was one main challenge. Another thing, it was the data fragmentation. Data are in different places, that in different time zones, and to different projections. So we had to unify all of them. The difficulty to find and retrieve relevant data, and of course the lack of tools to download the data in a common space, because all these petabytes, we don't want to added to the user part, we're going to make it in our part. So think about to have petabytes or gigabytes transferred from a place to a place, quite efficient, and to run algorithms on top of it. So what were our main challenges? Of course, the research in academia, the data providers, because we are providing also some interoperability tools in order to further exploit this data, citizen scientists, private sector, as we are talking about the NAOs, and of course the standard development organizations. This is the EO4EU architecture. I don't want to be in quite technical details about this. What you want to have in mind, we are having data tier, what means that is all the services close to the data, how we are making this, if you can say, common umbrella in order to hide all the complexity of the data providers and the services. We are having ML and fusion algorithms in order to give to you to process data and to take advantage of it as a toolbox. We are having the front tier, the visualization, either it can be a command line, either if you want to be through the platform, or you want to use it as an external API. All these are provided to you. And the back end and the hard workers in order to, if you can say, to hold all this infrastructure and all these services transparent for many users, for many data, for big data, as we are having this, how to, if you can say the keyword, up and running. So why a user to use EO4EU? We are talking again that we are like a one-stop shop of data sources. We are providing a common interface in order to access all data providing from the sentinels and the data providers. We are having clusters on demand for big data analytics and for big data processing. So you don't need to have your computer dedicated in order to run a specific process. We are doing this work for you. Machine learning and fusion models already, for example, this fuel estimation and of course the wind prediction are already published and accessible to all the users of the platform. The integration of your own notebook to build, and of course AR, VR technologies. So an example, if in a simple word, I'm a user, I would like to enter to the EO4EU. Of course, I have to make a registration. A user enters to the platform. What he can do, he can search for the data sources that he wants to use. He can select them, he can create a workflow to use the predefined functions, start the workflow and get the results. So simply word search, creating a workflow. What is a workflow? A chain of actions. For example, I want to download this data and I want to visualize them. Two specific, if you can say, simple steps. Or you can use more, if you can say, advanced ML algorithms. And of course, you can start it and all the cluster is going to handle all the complexity, get the results, visualize the results. Another thing is to upload your own data. For example, you have your own data that you don't want to share, of course, with other users, or you want to make it public. You can integrate it with already data providers, or you want to use, if you can say, for you processing capabilities in order to make the process for you, or to use the machine learning of the EO4EU with your own data. So all these things are also a possible chain of actions. Another thing is to upload your own notebook. When I mean notebook is from quite common as Python scripts in order to create your own, if you can say, decision support tool, or you're having something in your company as a decision support tool and you want to integrate it directly in the platform. And of course, you want to use it as a black box. I'm going to show you also this functionality that we are having services. I'm having my own code. I'm having my own things. I want the processing and probably to upload something to the data, to use some chain of actions, get the results, or I want to make it as a daily request. For example, what Dimitris show us is a daily fuel consumption, or for different, if you can say, vessels. So you want to run it multiple times in a day or with different weights. So what you can do is to access externally EO4EU and run it as a service, as a black box. What you can see here is a little bit the the dashboard and what we are providing to the user. We are having at the left part EO4EU, the home, the console, and some settings that you can use. But our main, if you can say, tools is the datasets, the workflow creator, workflow editor, data visualization, map visualization, file explorer, and XRVR. I read it quite quickly, I know. The first tip is, as I said, data sets. So we're going to search data providers. The next thing is to save this data, if you can want, the products of the data sets in a specific workflow. For example, I want to download or I want to create something empty in order to upload my in situ data. Then I'm going to write the workflow actions. I'm going to present it to you also this live, so no worries. I'm going to show it again and again. And data visualization, map visualization, and file explorer is to give you access to the data that you have already processed for a specific workflow. What I want to know is we are quite common in APIs, Elasticsearch, and all these things. And of course, the XRVR application. This is the dashboard. You can see also that we are having integrated the notification. It was a comment from our users that, okay, I'm having a workflow. Probably this workflow has to make downloading of quite big files, like many giga. You have to process them. And this processing of the machine learning can last, for example, 1 or 2 days. So you want to give you the notification that this is processing. We need time in order to get your results. But in order to know in which step you are, we give you also the notifications. The knowledge graph, as you can see, for a specific, as we said, the common umbrella is what? You can search, for example, for the temperature. You are selecting ERA5, that is LAD coming from the ADA platform. You can select a specific area of interest. And then you can select also your specific time zone. Then our system is responsible to download all the data in the specific, if you can say, search of interest. And this is common for mostly all of the datasets. If the dataset in some way is providing search in order to search a specific space in the specific time, you're going to have a common interface. And I'm highlighting this because it is, if you're going to different Sentinels providers, you're going to see quite different services of how you can access this data. The building process is, as we said, what you would like to do. I'm going, for example, to have a data source. What means a data source? I want to get this data that I select, to have an output, to download this data and to save it in a specific file, and then you can do whatever you want in the specific building blocks. For example, here is an action in a specific, if you can say, action list of data download, processing hours to days of the specific data set, because ERA5 are downloading data hourly, so the user will like to make it in days, to merge the rasters per day, and then to process it in a machine learning algorithm in order to, I think this machine learning provides the danger of locust in a specific area. Locust is the small insects. And the data visualization, what are, if you can say, we can have charts of data, and we can have also ARXR. This means that you can have, for example, on top of an area, a 3D, a digital elevation model on top of your specific area of interest if you're providing this in space. Our use case, we are talking today, and thanks to Dimitris, about ocean monitoring. And here is if I would like to demonstrate to you that our platform is also accessible through VR and the Oculus Meta. You can see that you can select, for example, the data that you have already processed through our platform. This is, for example, our lab. You can select the digital elevation models that are created from the XR VR, and you can 3D process them. On top, you can take it from there to there. You can go to zoom in. You can show them. You can be inside. It goes also from there. Let me check another one. Here, for example, is digital elevation model about the danger of fire in specific area of interest in the fire risk probability in the summer season, for example. So I think also the VR is something important. Also, I believe if we can make something like that also for the wind prediction to be demonstrated on top of an area, and a captain before starts, if you can say a specific mission with a vessel to demonstrate all the circumstances of wind prediction coming from the sentinels in real time, I think it will be quite added value to the daily operations in the ocean monitoring. Okay. And also we are having an AR integrated augmented reality in an application that you can demonstrate you where are you, some specific, if you can say, data sets. However, the augmented reality in this application, either we are having ready, it was in the scale of a specific city. So if you're taking the data of a city and try to visualize inside your decks, you understand that we are quite small in an area. So this was the presentation of EO4EU. I don't know if you have any questions. And okay, then we can go to the real demonstration of EO4EU platform in order to show to you two real case scenarios that you can also, I'm going to provide you also the code and all these things. The first thing, how you can upload your own data. For example, Dimitris has provided us with data coming from a vessel and some weather conditions of the vessel. And from this, if you can say CSV, we can predict the fuel consumption of a ship. So I'm going to demonstrate this part, and of course we can already show you, and I'm going to show you also data coming from the Sentinel, how we can run these workflows, how we can make also fusion algorithms in order to predict the wind. These are the two main, if you can say, scenarios. I would like also to update that for the weather conditions, with the cooperation of Dimitris, we have already tried to integrate NOAA as an additional data service that we hope quite soon to have the same, if you can say, weather condition provided from CSV also inside our knowledge graph. Just give me a second. Okay, I believe that you are seeing my screen. Okay, you can.
Yes.
Okay, perfect. The first thing that I just jump in is that we have to access our dashboard. The dashboard. Let me add. Just give me a second. Okay. This is the case of the platform. Okay, share my screen again. Perfect. Okay, so the first thing is that you have to log in the EO4EU user management service. Of course, the first time that you're going to log in, if you don't have an account, the first thing that you have to do is to create an account. What we need for you is just first name, last name, email, username, and password. This is the prerequisites, if you can say, for this registration process. The other thing that probably they're going to need is to create also from the Google Authenticator is like probably something like that. If you can see in my screen, you can't. You can't. In the Google Authenticator is a service in order to have two-steps authentication, and that is, for example, for security reasons. Probably for some cases, we are going to deactivate this, but for now we have to get two-steps authentication in order to access our platform. If for example, we are going to have a little bit time in order for you to get a registration and to help you after this presentation. And we're going to have time, if you would like to register, to help you with the registration and the setup of the authenticator, okay? Okay, so if we're going to register in our platform and you log in, you're going to see this specific, if you can say, dashboard. First of all, you can see here we are having the description of all the functionalities in a specific manual that you can find also here as a user guide. How you can use the dashboard, how you can use the data sets. So one important thing is the user guide. And the other thing is that we are having data sets. For example, you can select here Sentinel, for example, and you can receive all the data that are coming from a specific Sentinel. Sentinel-1, Sentinel-3, Sentinel or ERA5, for example, ERA5, and we are selecting, for example, Adam as a service. So we're going to receive the specific ERA5 datasets related and integrated in our platform. The first thing is that, first of all, we can create, as we said, a workflow in which we can upload our own data. And we want to process our own data. So we don't want to use the data coming from the EO4EU. We have our own data that is private and we want to upload it. What we are going to do is the following. We are selecting workflow creator. I'm going to add a name in my workflow. You understand that a user can have many workflows. What is a workflow for us? Is a list of actions from the downloading team getting the results. So let's make a test CSV that I'm going to create today. I don't want to add any data that I have already processed, seen, saved in my space. This is my products, if you can say. It's like you're going somewhere and you have some favorites that you have already accessed. And I'm creating a workflow. This means in my workflow editors, I'm going to see a draft workflow. Okay, what else I can see? I can see, for example, other use cases that I have already run and I have already stopped. Okay, so the next step is to view this specific workflow and is empty. What I'm seeing in the left part, I'm seeing all the actions that I can do provided by EO4EU. What I can do, of course, is to have a data source. What means a data source? To have a specific place in order I'm going to save my data. And I'm going to have a data output. Of course, I'm going to have a file system. And for the use case, what I would like to do for the CSV that Dimitris has already described is to predict the fuel consumption. So I'm having here for ML part, use case to wind production, fuel consumption, I'm sorry. And what I have to do beforehand, because it needs some processing of all of this, is to run use case to rolling average. How I'm going to check this? In the manual, we're providing you all the steps in order to run successfully your workflows. What I need is a fuel consumption. What I need also here is a rolling average. Okay, so I'm going to. Also, you can see information in needs of specific, if you can say, functionality. If you don't know what is this, we are providing you information when you are seeing here the dots of information. Use case to rolling average. It takes an input as a CSV. It provides an AMP array, and he applies a rolling average computation on input of a CSV. It's irrelevant for you. It's something like that the user has provided and has already, if you can say, be in a chain of action. But I haven't uploaded my data. So I'm pushing these 3 dots. I'm selecting the specific file. This is this zip. Okay. And upload it. It needs some time. Just give me 1 second. What happened? Okay, it needed some time. You can see here that in situ are successfully uploaded. I'm sorry for my internet connection. So what I'm going to do is I'm going to save it as a workflow. I can use it I can further edit it, remove something, or I don't want to change in my workflow. And I'm just, if I want to start this workflow, the only thing is to publish it. Okay. So for the EO4EU is publishing, is in this state. And you can see here in the left part that a workflow test CSV has already successful and the test CSV is running. For which parts I'm going to go through, the preprocessor, the fusion. Preprocessor means the downloading of data, the fusion, the machine learning, and of course the post-processing of the data if you want to check it. You can see here also that if I'm going to view my data, preprocessor finished. So probably the downloading of data has already there. Yes, it is also in the notification. Then is going the fusion that it has started its pipeline. Okay. Can I see the data until now downloaded in my area? Of course, I'm going to the File Explorer, Test CSV, and here I can see in the source file the in situ of the CSV. Okay? I don't hear. So until our service is going to be downloaded, the next thing is that I want to download data coming from the Sentinel. Okay, because for the wind prediction, in a specific use case, we were selecting data coming from the Sentinel-3. So Sentinel-3 data, what I have to select in a specific polygon, we want to provide probably wind prediction. Wind prediction, of course, as you understand, in order to be used for the ocean monitoring, we need some space of sea. Okay. So if you're going to use case 2 or the ocean monitoring or the Sentinel Hub, we have already tested in the sea, as you understand, about the ocean monitoring. So I'm selecting the rectangle. I'm taking a specific place of area in the water. What I can select, for example, is for a specific period of time that is valuable for me, let's say 25. Oh. Okay, and then generate the script. This script is all, if you can say, downloading process that we have to pass in order to download data from your Sentinel Hub. And of course, here you are having all the meta information probably that is useful from your data processing. People from the decision support in specific areas and specific companies either need the data, also they process their metadata. So we are providing you both this meta info in this Python script. And what we would like to do for your script, just to save it. And here you can see that I have in my product that is my favorite provided for a specific area of interest that I would like to use, that I want to select it. Okay. This is one part. And we are going again to the workflow editor. We are going to hit all the actions, but I want to show you also another way in order to process the data, because all the decision support teams, they would like to use it as a code, as an external API, as a notebook. It's something useful for the users. So I have already created a use case to wind prediction notebook. This is like a Python script that you can either run it in specific blocks or as a notebook, or you can run it as a whole as a Python script. We are having here all the libraries that you need to install. You have to define your username and password as it is described in your registration, what you are going to use here as a username and your password. You have to also write it here. And you're going to need your OTP token. What is that? We are saying that is coming from the Google Authenticator as a two-steps authentication process. The next thing is that you can check all your workflows. Just give me a second. Probably I have to go back again through this process because I was it was deactivated. Just give me a second. Okay. So what I have to see here is that I'm having already one published workflow with the name test CSV. It is what we have already seen inside our, if you can say, in the workflow editor. The image of this. Also, you can see my stopped, if you can say, workflows. Yes, I'm having two stopped workflows. It is the same image from my dashboard. Okay, what else I can do? I can set a workflow. Another thing is that is quite, if you can say, important, is that I can have my own downloading script, that I'm having the downloaded script that we have seen before, or you want to add something as a start date on a specific date that it doesn't exist in the knowledge graph because I'm searching the data coming in 1998. Okay, that is quite past. So I want some small changes. I can load my own Python script in order to download data. I can encode it. and create a workflow with these specific datasets. So with this, if you can say small chain of actions, what you are having right now in your dashboard is a new workflow with name use case 2 wind version 1, as I have write it here. Okay, and what he's going to download, the Sentinel data. For example, Dimitris has given to me, excuse me, that we can run, for example, in order to show with specific hurricane or specific bad weather qualities in 2020 for demonstration reasons. So for this point of view, I created my own script to download data and I put it inside EO4EU. Of course, this data are going to be validated in the second, as a second step from the preprocessor before the downloading by providing my own data. So I'm giving also this option to a user in order to make something. Okay. For the wind prediction, what I would like to demonstrate, of course, I want a data input, data output. Data input right now is the script that I assigned as a Sentinel-3. Okay. I would like to use case 2 array conversion because these data are coming in as a grayscale images and I want to create it as an AMPI array because my machine learning that Dimitris presented take a specific array and provides a specific, if you can say, prediction in the area of interest about how is going to be the wind in the specific, if you can say, place. Of course, I'm going to add it as a customer face in order to demonstrate if any data as a map from the Sentinel, I would like also to visualize because I wanted to do it as a user. So I'm also save this process and publish. Okay, coming here, I can see, of course, I would like to see what is going to be my workflow. Oh, it hasn't started yet. Yes, it's in publish. What? Ah, I didn't push the publish button, probably. I'm sorry.
No, just refresh, Kaki, yes.
Ah, I'm sorry. Okay, yes, it's published. Okay. So right now I'm having two workflows. The first one is use case 2 wind prediction. The other one is about the fuel consumption. What is presented, if you can say, in the file explorer. You can see here, for example, wait a minute. Downloading, it needs some minutes. It needs some minutes in order to download the data. However, what I can say, okay, probably I'm going to make a refresh. We can download the data, we can visualize the data, we can check, yes, probably something. No, the preprocessing. Okay. I am having also some network issues because I'm in a close to sea area and we're having many, how to say, energy breaks in our grid system. I don't know why, probably because a lot of people are coming and using their machines, whatever. So let me check to establish my connections. Probably Babis can have a better connection, but until now, do you have any questions?
No, Katja, everything is clear for the moment. Thank you.
Okay, so until we are having this workflows running because they need some time, as we said before, and the processing, do you need to have some hands-on? I have prepared also a pack of a zip for the people that are here in order to share the notebook that I have shared today, the libraries that you need, probably a downloading script that you have for the Sentinel Hub, and the CSV that I have already used for the one of the use case. So I think that I can upload it here as a zip. Okay. My network is quite a mess, I'm sure. It says uploading, just wait. Okay. Any other questions?
Probably not the moment, but before I think before the hand session, to make clear if they have a registration problem, if everything's okay.
Probably we can do the following. We can, I can send you right now, we're having all technical support. Take me as an email that we can be 24/7 and say providing your questions or to make a short call, or I can leave this call open for around 45 minutes. If you need any help with the registration, with the OTP, with hands-on, to help you with the notebook, to run your own code, or you can also send to me as an email in order to support you. I'm more than welcome.
Katja, yeah. So from my point of view, yeah, of course I could.
From my point of view, as a technical.
Clear. Yeah. No, I'm saying as you know, my role is hybrid here, an end user, and technical expert, if I might say. So from my point of view, it would be pretty straightforward how to run the zip pack that you gave to us. But I think it the actual end users, meaning, for example, the captains that are currently participating in the workshop, they would need the time to familiarize with how they could use the platform or the scripts, and training, appropriate training, to understand how they use it.
Yes, of course. That's why I'm also adding the EO4EU support, that is the technical support, in order to give time also to the users for, as you said, to familiarization, download data, update anything because I made the demonstrations, we are having the video, but probably it needs more time in order to be familiarized, to make some efforts and then come back to us with some specific errors. And Marika, please, you are having a question. I'm sorry.
Yeah, it's not a question indeed, but only to stress that for the registration, the user registration process, we have tried to ease this registration process, and we have removed the OTP configuration. So new users should not have to configure the OTP anymore. And for the existing users, they might have this OTP configured, but we can disable it in order to make things easier. So please let us know if you want to disable it. But for the new users, there is no OTP to be configured anymore.
I think, yes, Marika, thank you for this comment. That's correct. The only thing is that we have to update accordingly also the service in order to log in through the UMM, to update also Marius, because right now OTP is needed.
Well, I think that we are aligned. I mean, because we have aligned the configuration of the key clock production key clock instance with the development one. So I think that everything is aligned.
Okay, perfect.
So, Katya, the script that you shared, it is the whole workflow from data acquisition up until fusion.
Yes, the only tricky part that I want to say is that you can see also, let me share also again my screen. It is for example, for the wind prediction is from the start to as you said, till the data acquisition. Here you can see also how you can get the contents for the specific workflow. The only tricky part is between the create and the start. If you are for the first time, you have to go to the workflow editor to create the sequence of the diagrams, as I did it also today.
Yeah.
After that, you can select start, stop, restart if you have stopped the workflow, update the workflow with the current date, for example, the date today. Rerun the workflow. You can do it again as a block job, as a daily job. But it's from the start till the end. The only thing is that warning that if it is the first time, we cannot create the list of actions through the API. You have to go and draw it, if you can say, only for the first time.
Okay, and this is parameterized. We can select the time period, right, and the location, the spatial.
Yes, you can parameterize. Yeah. The only thing is that when you are updating the script, just after that to encode it in base64, that I'm having also the code here.
Okay.
You can see here.
So we can use this. Yeah.
Yes.
We can use this to continuously update our models with.
Of course.
With the latest, wind speed prediction, and this is from weather ensemble models or NetCDF or other.
I think that there are TIFFs that are coming from the Sentinel Hub in grayscale TIFFs.
Okay, you said that.
Yeah,
and you are using the.
It's the Sentinel Hub that we have discussed together.
Okay.
And we can change it. We can also update accordingly these data sets.
Okay. No, perfect. This is very crucial, for example, for ambient weather phenomena continuous monitoring. So it is of great value to us, possibly.
Yes, also I think you can run it for example, a specific workflow for a specific area of interest, for example, Europe, and then you can have or a specific, for example, the Mesogeios in English.
Mediterranean.
Yeah, the Mediterranean Sea, and you can have another workflow, probably updated with the dates for another location. So instead of changing the two things, you can just daily or hourly update the weather data coming from different, if you can say, directions and orbits of the vessels, trajectories.
Great. That is really important. That is really useful. I mean, it seems that it could be really useful from our end. I will digest. I will consume the script, and I will try to disseminate. The results, or try to familiarize the end users on how they can consume
this support system. Yes, exactly.
Yeah. This forecast. Okay.
I don't know if in the map visualization, for example, right now, I'm having some data. For example, you can see here it is in grayscale, the TIFF layers, but you can see that that you can upload many tiles on top of an area that you have selected. Right now we have selected data, okay? What the Sentinel Hub, from what I understand, is you were selecting a specific bound box, but he retains a specific area of interest that is close to this bound inside in this bounded box. And I think it's also from our script that I have digested through the notebook. So we're talking about these boundaries. Okay. Of course, if you have any, I'm going to update you about this, about the OTP. If it's not needed, it's more than welcome. I'm going to send an update in today, if you can say, to update the exact shipment I'm going to send to you. That's all from our part.
I have a question about when I'm trying to upload in the Colab the files that you sent. I have to unzip them.
You have to unzip them. You are doing two things. When you're going to the Colab, just let me share my screen. Okay, when you're going to the Colab, you can create to upload a notebook.
Okay.
You browse. Probably if you're going to extract it, you're going to have a folder in which you can see a file with IPYNB ending. Okay, so you open it. And all the code is going to start is going to open. We need two things more. You're going to the files in this icon in the left. You're uploading. You see two Py scripts, OpenEO. Okay, the first thing is this is a library that we have created inside EO4EU platform. And another script that is the script for downloading the data. So we're having notebook uploaded and two files of Py that probably they're going to be requested. If you run it also import libraries and you don't have openeo.py, they're going to say that I cannot find it. Please give me some access. And for the username and the password, you are assigning where. Do you see the key here? Left part, you're selecting. I'm having, for example, and you add new secret with the name username and with a name password, and you are going there and put your own credentials used by EO4EU dashboard.
Yes. Okay.
And everything is going to be automatically from there.
Okay. And can I say if I want to change can you show a little bit the script? That is
For example, here right now I'm having a script. This is the script. If I'm going, of course, I can do it also updated, but for example, I can change the date.
Okay, so you change the date from here.
Yes, you can change from here. I'm having also an update function in order here that I can make an update, but yes, you can update it directly from the script. Also, you can update the bounded box. Bounded box is the rectangle that you want to ask for it. So, sorry, where is the bounded box? Here.
Okay.
So you can also change it. Just remember that I want 4 points as a polygon, as a rectangle in order to be assigned. These things, these kind of things. Or no, I'm sorry, the bounded box is the left upper corner till the right down corner. It's something like that. You are creating the two steps and they're creating the rectangle. Okay.
Okay. And another question about the time range that I should change. I should choose is something that is. Can I choose 10 days before? For example, I want to predict.
Yes, of course. You can change it directly in the script or in every script that you are that you can find inside, for example, the EO4EU. For example, you can go here in the EO4EU and you would like to select ERA 5, for example, or UMECHAT, something, fire, that gives you fire risk mapping. Okay, for the fire risk mapping, you need to say some things like today's Friday 13th. It's a good day to have the call. The month is June, minutes, year. Okay, I generate a script. This script, I can take it and I can put it here. And then what is going to download it from the EO4EU is going to download you the 3 files for the fire prediction coming from the UMECHAT.
Okay, that sounds great. So, and about, for example, we're discussing, sorry, the one that we had about the fuel prediction. If do we need a specific time range before, you know, you have to set a specific time range in order to be able to I'm trying to remember the word, sorry, predict about the fuel consumption that you will need. Do you need something, do we have specific time rates that we need to set up here? Because in the UMECHAT, we know that, for instance, we may need some specific time range. Here, do we need that? It's the same case.
I think Dimitris can answer this,
Yes.
but I believe right now we are talking about CSV. So CSV is something like that Dimitris providing from the vessels, and we are uploading in our code. However, if we are going to the NOAA, probably we can be more dynamic and having, for example, specific date range 1 day before, 2 days before, 1 day as a prediction in the future in order to download data. So we are waiting the NOAA, and then what we are having in the CSV is some parameter from your vessel, from the sensors of the vessel. But the weather data are going to be directly from the NOAA.
Okay, that sounds even greater when you have such a huge, so few days. You have to choose us a few times to be able to run the prediction. Thank you. That's all from me. So on the same time, I have to say that we are building a user guide. We will enrich a user guide that will be in the share folder. So we'll be able to see more of these things that Katya and Dimitris have presented. And of course, if you have more questions, we'll be happy to, so that we can support and enrich the user guide more if it is necessary. That's it for me.
Okay. If I can say also a few words to conclude the meeting. I think we are in a very good stage, let's say, regarding the implementation and the integration of the EO4EU platform to the use case and to our premises optimization algorithm. We have run, as we showcased, some tests, preliminary tests. But now what needs to be conducted in order to complete a full cycle, I guess it is to establish a continuous interconnection between the platform and the entire models in our premises in order to first validate continuously the weather forecast in our routing optimization setting, getting multiple forecasts and cross-validate them, for example, could be a way to have a more, let's say, concrete basis concrete benchmark for the weather data that we're receiving. And of course, validate them, integrate them, and validating them against historical data continuously. It's which it has been done, but needs to be appropriately scaled up with more routes and with more data, operational data. Is another step forward. And of course, at some point, this needs to be transferred on the edge on the onboard version of the routing optimization module, where this will be validated in a real-world setting. There we will have, the ultimate testing and validation of the EO4EU powered routing optimization module. That's what I wanted to say. I want to thank again all the participants, of course, and specifically the participants from Danao Shipping. Again, we understand that your time is limited, so we thank you very much for participating. I guess Katya and Christina, you will share in due time a questionnaire to be completed, right? Okay, so I guess referring to the people from Danaos, there was a lot of different things to take in into today's workshop, but I believe you got the bigger picture and a good feeling of what is the functionality and the capabilities of the platform, and how we, as end users, as a maritime company, how we aim to utilize this, to exploit this. So if we did this and you got this feeling, I guess the purpose of the workshop is served. And yeah, we are also going to wait for you to fill the questionnaire to get a more concrete picture of how you view, your view on things and the platform and the integration of the platform from our end. That's all from my side.
So thank you. Katya, do you have anything else to share?
Of course, as Dimitri said, we have a lot of we did a lot of work till today. We need a lot of, if we can say, some updates in order to demonstrate more and to facilitate the users and what was, if we can say, the dream of EO4EU. We are working on it. I would like to thank you all of our, if you can say, partners that are helping us, and Dimitris, of course, and Christina. Dimitris for the technical, if you can say, insights for the ocean monitoring, and Christina for organizing all this end users workshop. We need your feedback, we need your questionnaire, we need to understand if it's something useful from you and how we can make updates in order to facilitate also your experience with the platform, because the technicalities are there. Probably we need to facilitate things for you as a graphical user interface and these things. Thank you for your time. I don't want to waste your time. I know that your time is valuable. Thank you all.
Thank you, Katya. Thank you, Christina. And thank you all.
Thank you,
Bye,
everyone.
guys.
Thank you,
Thank you.
guys.
Bye-bye.
Bye-bye.
Thank
Bye.
you.
Thank
Bye-bye.
you. Bye-bye.